Wait, I'm going to count to 5 and I'm going to click over. 1.
Welcome to the Plasma Frontier.
I'd like to welcome everybody today. We've got Cleve, we've got Allison, and we've got Joe. And we're basically going to be talking, this is like part 2 of what Mike was talking about in our previous podcast. And we're going to go in a lot deeper with that idea of how do we deal with coils and etc. So without further ado, I am Frazzle, and we're going to start with plasma, toroidal mathematics, and it's just an introduction to it. I want to thank the folks that have done the rodent coil mathematics. There'll be a link to their videos in the notes below. We thank all of you for your donations to the Plasma Frontier. This keeps us going and keeps these podcasts alive. It costs us money for bandwidth and for storage of data, and we really appreciate you guys that have been sending funds in. Last time we talked with Mike Naship, and Mike had us put together what he called the infinity loop. And I'm going to bring up a drawing, I think. Let's see. Anyway, if you remember on this one side was red and one side was blue. In the middle, there was a yellow dot. If we take Mike's symbol, and I'm going to tell folks that a lot of what Mike talks about is in symbols. Now, some people will think it's actually the device, and in many ways it is. But what it is a fractal. It's the smallest part of your devices. And it keeps us, this particular memory piece that we've got here, just kind of keeps things straight in our minds. It's part of the pictures that we use to remember to make certain that we've got our circuits in order. Your next, the next picture that we're going to show is we're going to bend this loop just a little bit, and mine is really, really large wire, so I'm not going to be able to do the bend that some of the rest of you can if you've got Mike's infinity loop with you, if you've still got it on your desk. So I'm going to bring up the beginnings of toroidal mathematics. So let me go get a photograph. It takes a second for it to come up. And let's get in there. On the drawing, you remember that Mike started with a circle, which would be the outside ring. This is the one. And he says you can divide this circle as many times as you want. You can do it 360 times. You can do it, 800 times. You can do it 9 times. We're going to start with the basics. In this particular drawing, we're going to bend Mike's infinity loop just a little bit. And I'm going to draw on this. And we'll use the blue color. And we're going to bend it up so that it looks like this 1, 2, 4, 8, goes down to 7, 5, back up to 1. So all we've done is we've just made this 2 circles on each side, right and left, and made them kind of square so that they would hit the points on the circle. What Mike was talking about is the magic of the device is right here in the middle, where he's got the yellow. And it's from that yellow dot that you get radiant energies, electromagnetic, expanding, magnetical, from the center. In he's got them wound so tight that there's a very small spark gap. It's very, very tiny. And because it's nano-coated, it transfers from one wire to the other with not a lot of loss of power or a buildup of power. It fully jumps. But it sets up this field in the middle. I'm going to erase all. If we look at the outside of the circle in the toroidal mathematics, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. It's basically what we call a base 10, which means there's no zeros, and it's an addition, so that on the outside of the ring, 1 plus 1 is 2, and 1 plus 2 is 3, and 1 more is 4, and 1 more is 5, and 1 more is 6, and 1 more is 7, 1 more is 8, 1 more is 9. Why is this important? When we do the wrappings of our coils, I'm going to change color right now, and we wrap around the coil, we have a 1, 2, 3, 4, 5, 6, 7, 8, 9. If we go around again, since we don't have any zeros and place setters, what would have been a 10 over here is basically 1 and 0. You add them together, and you end up, it reduces down to 1. We go around to the next one, and that is a 2. And that is a 1 plus 1, or 11, and that reduces to 2. And it continues on that way. The notion that what happens is we're counting basically the spaces in between the coils. We're not multiplying, we're just adding all the way around. If we ran a solid tube all the way around this, or if we ran our wires so close together that there wasn't any spaces, we would only have a 1 all the way around. Clear all. So it's the spaces that are important. In the next set of mathematics on this one, clear all, we have the 3, 6, 9, and that's this one in the middle, and it's 3 to 9. This is part of the oscillating circuit, and where you have a travel of information or ions around the outside here, and in the 1, 2, 4, 8, 7, 5, 1, it's a rotating set of numbers in the middle, and it'd be much easier if you go through the 2 videos that I'll have posted in below to explain this better. What happens in the interaction of that first set of coils here and that set of coils there is you have a third frequency that forms. And that's this oscillating, this 3, 6, 9. And it goes back and forth. What happens in the toroidals is that actually forms a different part of the field. When you add more coils in the middle, you're multiplying the numbers in this part of the circuit. The result is you have more output in the center that causes a reaction in the center one that increases this 3, 6, 9. Now, when you go into the Tesla numbers, the Tesla philosophy, he says, people don't realize the importance or the power of the 369. They basically free. This is almost an AC current that runs in that one. The next part that we look at, we clear all, is the number 9. 9 by itself doesn't do anything. And everything that is in the 9 progression of numbers, when you start adding up, all reduces back down to 9. 9 is a very interesting number in the mathematics. Okay, clear all. Let's stop share of this one. And I would like you to kind of take a imprint in your mind of this particular drawing. This is the basis for almost all the circuitry we're going to be talking about in the next couple of weeks, in the next videos and stuff, is the relationship of, give me a color, give me a pen, here we go. The relationship of this wire, we call it as part of the circuit, to, change color, this set of wires, and in relation to the output effect of the 369, which may or may not be wires. The Rodin coil folks have worked really hard to set up a physical representation of this 369 in their coils and in their mathematics, because they're realizing that a lot of the electrons travel from one to the other across the peaks. It skips. This is part of the multiplication of the circuits. Mike was talking about this earlier. And when I quizzed him about power wrapping around it, he says, and if you remember, you have one batch of current of a certain frequency runs in the valleys. Okay. The other set of currents and frequencies run across the top. This is where that idea comes from. And this is where we start with symbols, and let's say a picture is worth 1,000 words. A symbol is worth 1,000 pictures. And what we're doing is just taking a few of those pictures and applying it to the symbols. And we'll be applying more and more pictures and descriptions as we go on. It's super important. Clear all. The next thing that happens, we're going to go to a three-dimensional representation. Let me share another picture. We'll go to that. Yeah. This wasn't the one I was going to pick up, but that's okay. The doubling circuit, as spoken by Rodin, by Marco Rodin, is that he took that same drawing that we showed just a moment ago and applied this schematic to it. If you view the circuit, this diagram, not as a flat two-dimensional drawing, but as a three-dimensional sphere, and you rotate it, Rodin's drawing, which is this one, morphs into the other drawing, which looks like Mike's infinity loop that's been squished into square edges. There are, I don't know, hopefully I've got a GIF that'll show that. Let's see if we can stop share. Let's see what we can find here since we went that direction. It's okay. Maybe it's this one. No, this is the two of them side by side. We start with what we began with, was Mike's infinity loop, which is that circuit, that set of lines and drawings, symbols, and then rotated it 90 degrees as if it was a basketball, a hollow or a translucent basketball, and you turned it. You can then have Marco Rodin's image, which is that one. Both of them work, they're a representation of the same design, of the same circuit. It's just from being viewed from a different angle. But this is showing it as in both forms at the same time. Stop share. Go to the next image. When we look at what happens when you have an interaction, and I'm going to do two images. I'm going to go back to the first one, and then I'm going to go to the progression. Remember, of this drawing, keep this in your mind. Stop sharing. And we're going to go to the next one. Okay. That vortex that forms on the inside, which is the center part of it, is basically this drawing. That sparking out of the center, which in Mike's would be right there in the middle, right there in the middle, yellow, spirals out and around and down and back in and spirals again. Meaning that if you take and ping the outer edge of your toroid, you are in the additional ring, the 1, 2, 3, 4, 5, 6, 7, 8, 9, around the outside edge. Clear all. Let's do that again. As that comes out, it spins around the equator, filling up the outside of the toroid, which is like, this is a cross section of that toroid. It looks like a big old donut with a hole in the middle. We're just going to go around the equator of that toroid. That's that circle I've drawn. This circle is that 1, 2, 3, 4, 5, 6, 7, 8, 9 around the outside edge. Most of the folks that in the early rodent, they were pinging that outer edge. You're in the 1 plus 1 plus 1 plus 1 all the way around portion of that toroid. What am I saying? Stop share. Next picture. Well, that didn't come up as well as I had hoped. Well, that's really sad. What the drawing really has, we'll draw on it, is that toroid. And remember, the equator goes around the outside, just like the rings on Saturn, like so. And it forms this vortex in the middle, this hourglass, that jigger is my favorite. In this drawing, what they're saying is that actually comes out and around and goes back in. And it's that interaction in the middle, clear all, that is Mike's, let's do it right, infinity loop. In the middle with the magic happening smack dab in the middle. I want you to think about this for a minute. This is the symbol that Mike was talking about in our last video. So that in the toroid that forms, your electrons come out, spin around, go back in, change direction. They do it on its own. It comes out, around, and back in. Okay. What Mike was showing you was a symbol. Symbol is like having 1,000 photographs because you have a lot of things that it applies to. In the middle, you have this yellow spot with scrubbing. It causes in one of the vortices this loop. Let's see if I can get one color. See if I can get the shapes. If I can figure it. There we go. Comes out, spills out, goes back in. Comes out, spills out, comes back in. What's interesting is when we take a look at what is happening, we have the magnetical coming out of the top, rolling around, and coming back in at the bottom. It's just like the planet Earth or any of the other planets in the galaxy. Even all the galaxies do the same thing. It's this toroidal flow. At the same time, change colors. See what one. I'm going to use green this time. We have a gravitational, and that runs the counter current that goes around and comes back in. Comes out at the bottom, goes around, and comes back in. Comes out of the bottom, goes around the outside of the magnetical, and comes back in. Goes out of the bottom of the outside of the magnetical and goes back in. When Mike said it goes on one side of the wire in the middle, flips over to the other side of the wire, goes around, comes back to the middle, goes around the outside and comes back in, so that you actually have both surfaces, two tracks, working. The field that forms is exactly the same thing, only in a bigger scale and in a different direction. You have the inside where the gravitational comes like from around the inside and goes in and around. Then it goes around the outside, out the bottom, around and in and back in. The magnetical does the same thing, coming out of the middle, going up, around on the inside of the gravitational, back in, going around on the outside of the gravitational and back in. So you end up with multiple layers of that field that you can't see, but they're there. It also shows up when we do the magnetic fields with neodymium magnets and the sheet, which reminds me, I forgot to go retrieve my sheet. But what you'll see that the fields are actually three-dimensional. They're not two-dimensional. So this is two different donuts making one inside the other. And the more that we look at it, the more we realize that there's almost an infinite number of these interactions from one to the other. Stop share. I'm sorry that one didn't show up as well as it could have. Next photograph. The rodent coil folks took a look at their wires and took a look at the interactions and the pathways around the outside edge and started assigning numbers to them. And why? Because they were starting to pick up differences in charges. You know why? They just did. Because they're using wire to represent the toroidal fields that we are going to be producing without the wire frame. What they found is that there was a mathematical progression in every direction, just the same as what was on the outside of the toroidal field, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, to 9 around the outside edge. They got the same equivalence on a 1 circuit rodent coil that went through this number progression. When they went to 2 circuits, they had two separate sets of fields forming, but they had the same numbers on the inside, 1 through 9. The outside edge, the equator, remember, is the +1. We start taking the numbers through the middle, and you'll have to go through their mathematical analysis, because what will happen is it goes 1, 5, 7, 8, 4, 2. But what happens is when you get the progression of numbers, you've gone beyond the 1, 2, 3, 4, 5, 6, 7, 8, 9. You're getting into the higher numbers and reducing them down to the core numbers, which is 11 would be 2, 12 would be 3, 14 would be 4. 14 would be 5, I'm sorry. As I said, this is not my strong suit, but all we have to do is realize that these numbers are there, and it is important, and it works. In many ways, when we cut this toroid field, this donut, in half, we get back to Mike's infinity loop. Change color. We have blue coming around on that side. We have red on the other side. The magic is in the middle, in yellow. And not only does, I'm just going to use purple as a combination just for tracing, it comes out, goes around, goes out, goes around, changes direction a little bit, goes around, comes up, changes direction, goes back in, goes across and come back, and you get this circuit that goes around and around and around and around, and it ends up showing up as this big donut shape, this big toroid shape. I'm going to go to the next one. I want you to take a look at those arrangements and numbers, because there's kind of an interesting thing, and the guys that are doing the mathematics, there's kind of a, let me get this one, stop share. They actually laid all the numbers out on the outside shell. Let's see if I've got it. No, I didn't do it, so I'm going to go to the game. They went through and they found out that each of the spaces on the coil where we had the interactions were divided up into boxes. I'm going to draw the lines on the boxes. And inside each of those boxes, looks like tic-tac-toe, there was only the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. What was interesting is in some of the circuits, that particular arrangement of that solution mirrored to the one beside it. That is one of the ways of doing the mathematics. The other one, clear the lines, was the game Sudoku, which means not only do you have 1 through 9 in any given box, but you also have that same set of numbers, 1 through 9, in that direction and in this direction. So that to solve the Sudoku problem, the game, that particular page, it had to add up all 3 ways. Both in all the boxes had to have the same arrangement of 9s, 1 through 9s, and in each of the directions, 1 through 9. They're all. When we get the practice sheets, stop share, in Sudoku, the game begins looking something like this. And you have to, these are your known numbers on the game, and you solve for the unknowns. You'd have to solve for that one, and that one, and that one, and that one, so that they don't duplicate in the ones below. So if you put a 1 in that space, because it seemed to work out, there can no longer be, if you put a 1 in that box, then there can't be any more 1s in any of these boxes, no more 1s. And it cannot be any more 1s in that box, and you can't add any more 1 integers in any of the other blank ones in the same square, in that same plane square. Clear all. When the toroidal mathematics is solved in this way, and it's correct, an interesting thing happens. Let me go back to the other Sudoku box. And I'm not certain how well this will work. I'm using it as an example. When you solve for it, you get a pattern that shows up. There's a 9. There's a 9 there, and a 9 there, and there's a 9 there, and another 9 down there. And if we circle all the 9s, there would be actually a frequency that would show up. Well, what does that look like on the toroid? Stop share. Oops, wrong one, excuse me, I'm sorry, I hit the share photo. If we just circled one set of numbers, the toroid, and this one happens to have quite a few circuits on it, sets up another series of patterns, and it gives you the view of what is happening, the other frequencies in the giant toroid that forms above your Rodin coil, meaning that you have not only the outside energy. Now remember remember the first drawing that I showed you had the lines coming out in all directions from where the magic starts, in the middle of Mike's infinity loop, in all directions. That's what those black lines are all about. Okay. You have a different set of frequencies happening, harmonics. I'm going to introduce that word right now. A different set of harmonics starting that comes from the inside, if I can connect the dots, to the outside. And in this case, this would be our magnetical expansion. That's all the way around that three-dimensional, hitting all my circles. It comes around and goes back in on the inside. In addition to, if you just said those were just all the nines, there was also another pattern that shows up if you do the 3 6s in conjunction with it. And I don't have that drawing, but it's there. When Mike was talking about where we have currents jumping and you're in the multiplying, they're going from node to node, like the one little red light dot to the other red dot, skipping from the point of one of those mountains to the point of the next mountain to the point of the other, meaning that the electrons don't have to go clear down in the bottom of the valley and travel at a slower speed. They can be accelerated to the top one. And what this does is it sets up a vacuum between the two, allowing for a space to be filled in with more electrons. This is the beginning of toroidal step up, step down transformers. It is which is in the multipliers. The Rodin coils that are flattened are in the let's go back to that drawing. It's easier to explain this when we have the right photograph. This is a different one, but it's okay. Once again, you have pen, and I need a color. Let's do the magic. This oscillating with 9 at the top. Remember, there's more of them, like so. And we can actually look at our nanocoding, and we see these peaks and valleys in it. That 9, the electrons jump across it, and it increases the speed that it could travel. Okay. What's down at the bottom, down in the valleys, travels at a slower speed. It might even travel in a different direction. So you could have in around the mountains, so, and then at the top, across the tops. And because there's a difference in speed and possibly a difference in charge, one harvests from the other. Let's go to the next one. So once again, we're talking part of the toroid is formed in the middle, because you have the actions in here. You have your matter state, which is like your copper wire around the outside edge. Let's do that. That'd be your copper wire around the outside edge, let's say. Okay. This is your oscillating, and then you have another circuit, which is vibrating around it. It's not one thing happening at one time. It's not just one thing. It's a multitude of things. And shot share. We go to the next photograph. So it looks something like this if you have multiple circuits on your Rodin coil. You can have 1, 2, 3, 4. And each one of those bands will have a series of numbers and progressions. And what's interesting is if you take the different numbers, and if you go through the 2 videos that I've got linked at the bottom, you will start seeing that you have both the crystalline numbers and the Fibonacci numbers, and 9 in each one of them. And all we're looking at is to ping, sorry, go back to that one, try again. What we want to do, change color, is first ping here. In your first set of coils, this is going to get the expansion out and around, and it's going to increase this field. Later on, we'll be introducing more fields, not just in the circuitry around the single toroid, but actually distinct different fields, and having them interact. And depending on how you set it up, if you had another field set up over here on the side, this would be like 2 gears working against each other, but you're going to be in the multiplier, which is one set of 1 plus 1 against the other set of 1 plus 1. So you get basically the 2 times 2, because you have 2 toroids working like gears against each other. One runs one way, one runs the other. And you have a new space in the middle. I should do this. Mike's teaching us. You have one running one way, and you have the other running the opposite direction. In the middle, you set up another, in yellow, magic spot, where you have an interaction, where you have a whole new set of toroids being formed, bigger and better than the one before. Let me see if I've got anything else that I want to share with you right now. And this is, when we do introductions, this is super complicated when you first look at it. You go through the videos and they do a much better job of explaining it. And what I want folks to realize as we go forward is that the numbers are there, the multipliers are there. We are now taking the work that they've done in the theoretical and putting it into practical application. But the basis of it is in this signal, in this one. Now, let's see if I got one more picture to share with you guys on this one. We're just about to the end. Yeah, I've got 2 more. 369 can also be represented in the yin and the yang. It's just one more way of looking at it. And so you've got, it sets up motion. 1, let's see if I can get it. 1 working against the other. It's the same thing. And then we go to the last drawing. And so we can go into all kinds of esoteric talks about this, but at this point, it's it doesn't matter. We're just doing introduction. And our last photo. So you can get really, really complicated. And once again, we're talking about one side interacting with the other. And you can divide it up, you can put it into smaller parts, you can look at each section. On one side we've got the golden ratio, below it the Vesca Pisces, the square root, the doubler square, the square root of 2, the square root of 5, the square root of 3, pi, right angles, squares, cubes, hypercubes, all get involved with this particular drawing, this particular symbol. You could go with even the seasons of the year if you wanted to. In the middle, the same stuff. Summer, fall, winter, spring. You can look at field interactions. You can have one here, they go in there. One can be going one direction. One can be going the other. Same stuff. Goes that way. Goes that way. What I'm wanting you to look at is not that it's different, but it's the same. And it's the interactions, because it's the same pattern over and over again. You see this coming up, around, and back. Clear. Coming up, around, out, and back. Clear. Okay, stop share. All right, I'm going to bring the rest of the panel on. Go ahead and turn on your cameras, turn on your mics. We're going to do a few-minute discussion here. And we've got Patrick, who has worked quite a bit in the rodent coils. We have Joe, who has worked quite a bit with the rodent coils. I've done far less with these. I know a lot of the Tesla stuff that I've worked with. And so, Patrick, I'm going to call on you first, put you on the spot. What would you like to add to what I've talked with just now?
Well, quite honestly, you've covered all that I know, and then a lot more. I'm afraid that Joe's worked more with rodent coils. I'm somewhat limited with my experience. However, yeah, I've produced some simple Tesla type coils, and yeah, I've learned a lot today.
Do you have your big square one there, just for grins and chuckles? Okay, tip it up so that we can look down through the center of it, and up a little higher, please. Okay, what he's got there is basically Mike's infinity loops, if you can envision it now, and you've got a piece of iron ferrite around the outside edge through them.
You need to put it on the screen.
Even though they're not connected, the one on the left and one on the right, the fields interact because he's pinging that circle in the middle.
We can't see him really, Fraz. You need to put him.
Oh, yes. Oh, Patrick, you have to talk. I'm sorry.
Oh, okay. What's actually happening? We've got a neodymium magnet here, and we've got two coils here. And what's happening? We're alternating, pinging these two coils. And what's happening is that this is an amorphous core, and as the current flows through the amorphous core and through these coils, back down around the other side and through this coil will ping and stop the flow of energy and reverse the flow of energy. So we're getting a left and right flow of this energy, and so this is the way we've been mechanically pinging this through a frequency generator. So basically, as you'll know, that this, through the energy going through these coils, produces a current. So
Okay. Just so folks know what we're talking about, let me see if I've got a photo. Let's see which one I've got here. Far down. I hope this is right. Correct. What he's got set up, slightly different. He's got, basically you have 4 coils on the outside edge. There's one there, there's one there, and and those are one part of a circuit. Change color. And one there, and one there. Now, on Patrick's, I'm gonna clear all, he's got one there, change color, one there, one there. Same circuit. Okay. Stop. And but Joe, please, whose circuit, whose drawing is this one that I'm
That came
showing?
off of YouTube. It was a gentleman called on YouTube. He was using the name Guru to You.
Okay, and what year was this drawing sent off to patent? Do you know?
Not offhand, to be honest with you.
Okay, or who else was?
Well, I believe
using
this.
it?
I believe the circuit has been used a million different times. Floyd Sweeney. I mean, a lot of guys that played with magnetics. What they're actually doing, they're causing, like Patrick was explaining, they're causing a magnetic pulse to whip back and forth, and the coil on the left and coil on the right will pick up to collapse the field of the energy when it passes by. So you will actually pull the power off the sides. There's 2 center coils. The first one's the pulse. The other one pulses down, and they pulse back and forth once you get them running. So it's like that would be the motor and the starter, and the generators would be on the left and right side. And the 2 magnets in the middle, you have a north and south field, and they would switch poles. So when it went around, it would loop them back and forth.
They're all Tesla's work, though, aren't they?
Yeah. That's why I said the circuit. It's all the guys that came way before us, and Tesla had a big part of it, but a lot of other guys too that played with magnetics and that. This is, like I said, this has been around, and they all touched it and tuned it and touched. It's the same thing that we're doing. We're all getting bits and pieces and figuring a lot more out with them.
This is one of my favorite photographs. I show it to the team probably every 2 or 3 times a week. This is the same thing that Patrick showed on the lower right, and that's basically a brushless motor. But what's interesting is this device sitting right next to it is a electromagnet. It's an actuator. It actually causes the rod to move back and forth in the middle of it, opening and closing the switch. Okay. What this is a fan assembly off of a dishwasher. Okay. Go ahead and talk, Joe.
Okay, when Fraz showed the plasma coming out of the vortex of the Coil, that was the best display I've seen in a very long time. He was right on point with the explanation. I believe that you agree with that on that, Patrick. Like you
Absolutely.
said.
Absolutely. Look, this has been around for probably 10 or 15 years. In fact, I think
longer than that, my friend. A lot longer than that. Maybe about, well, Tesla, a lot of stuff we're going back to. You have to give the man credit. Even the maggrav coils that they're calling, they're Tesla coils.
It all does stem from Tesla, but a lot of people have done their own work with it, and different variations. And
I mean, that's the name of the game. That's how we invent. We all take information and ideas from one another, and we improve them, or we don't improve them. Let me rephrase that. You know, sometimes like this work here, we're almost understanding this. It's been around for 130 years. We'll finally get to the point we understand this. You would have showed somebody this 15 years ago. What I looked at it 8 years ago, and I was trying to figure it out. And I racked my brain day and night looking at this circuit. I got close a few times with some of this stuff, and that's how I got to the point where we are now.
Okay, I'm going to have to stop this one, and I've got to call it quit for today. And I want to thank everybody for input, and we're going to have a part 2 of this video here shortly.